तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
So far we have seen waveform analysis for combinational and sequential circuits using model sim for simulation, and the functional simulation was quite easy as such, with although it was a bit difficult to view the waveforms in real time. What we will do is we will summarize this model sim commands now. We will go one after another and also see in real time, although it will be a little difficult for you to view, and the same windows are once again made it bigger for you to view more clearly. So to start with, as a first time user, you will have to first create your project as such. So first thing you have to do it is write on your system desktop, which is this. What you see is a desktop here, and the first thing that you have to see is, look for the model sim icon here and double click on this in order to invoke the model simulator. So you will see a window opening here. It says model sim SC 5.5D, and you will get a window here and followed by one more window, and this one you can see here. The bloated up version of this is here. You can see this precisely. This is what you have. I will zoom it and then show you. And there was another window open besides that one. This is the main menu that you have, and this is the opening menu as such. And let us zoom it in order to have a clearer look here. See, this is the main model sim window, and for the time being ignore this, and this is the next menu that you have already seen. We have different options here. Let us say first you want to create a new project, then you use this create a project. If the project is already existing, you need to open that project using this, and if you want to view the documentation which is available as a help in a help mode, then you can use open documentation. Of course, this one will open the internet for you, and you can view the documentation in PDF format. And on the other hand, you can don't want to create any project straight away enter the model sim, you can enter through this also. And this is the main model sim window, and that thing is right here. So this is the model sim window, and let us go into these details later on. First just get a feel as to what it is, and we will describe all this in a short while. So if you want, you can zoom this once again, or it is already zoomed. Is it clear? Okay, it is already zoomed. So now what we had is this, and what we had one more, that was welcome here. can locate it here, so that you can see both the windows. This is what we have seen in a zoomed fashion. And let us say we want to create a project. So you just click on this. So it says it is asking for the project name, and you can also browse different directories here, and then go over to the decide directory, where you have located all your Verilog files. For example, let us say we will go up further. So it is in D directory, and user here, then say ROM, and one more directory called DVLSI, and then another directory called etc. And suppose we want to locate it here, so we will say open, and that is what you have got here. And this you can see this window in a minute, and before that we can key in here. Let us say we want sequential circuits, so we give apt name there. We will give sequential circuits underscore circuits. So this is the project name that we are going to give, and this is the directory in which all the Verilog files are located for this project. And another important thing is it should be in a work directory, and it should not be in IEEE directory, and you should switch over to work directory here. If it is not there, you may have to create. And let us say this create project we have already done. So what happens? It reports a project of this name already exists. Do you want to overwrite? It says. You can say yes or even no. Let us say yes. So what has happened here is, and you have a project here and library here, and prior to that what that create window was. So we will just have a look. The create window is actually this. What we had done is browse through different directories, and then put the decide directory and selected the directory that we wanted, and then we keyed in sequential circuits here, and we also ensured that default library name is work, and then pressed OK. So and it reported that it is already there, and that is why we asserted yes. And having done that, what happens? So this is the window. This is the real window, and so prior to that we had a summary here, and let us just read through this to make sure whether we have already gone through the step by step procedure. These are all the model sim command summary, and the very first thing was double click on icon. This is what we have done. This is the icon on your desktop, main model sim window, and welcome to model sim windows open, and that is what you have seen already. Then we had clicked on create a project in welcome to model sim window for a new project, but it was already existing, so it gave another it gave a warning, and we accepted that. And then when you create for the first time, you would have had a smooth flow here, and because it was already existing, this was slightly different. But anyway, for a beginner, the first time user, this is the best approach. You just follow step by step, and you would have learnt within no time, and the entire model sim is condensed in just some 16-17 points. So we can, it will be a ready reckoner for you to use, especially it will be very useful, especially for a beginner. And click on create a project in welcome to model sim window for a new project. That is what we had done. Create project window opens here, then type sequential circuits in project name menu, and also type the decide location of the directory where you have your Verilog file stored in the project location menu. This is precisely what we have done, overwritten actually, although it was already existing. And then also we caution that make sure work is entered in default library name. This also we have seen. Then said click on OK. In the main model sim window, click on library on the bottom left. This we have not covered, we will just see here. So you see here two windows here. If you see this simulator window, you can clearly see a library here, but it is in simulation mode because it has been it had just completed loading the sequential circuits, which I had already tried out. That is why we are in this position. So if you had created earlier, you would have got here a library and one more here. I think it is a process, we will just see what it is, library and project, right. Just click on library here. So, you see in library work pops up here, and that is what we want. There are other things, say IEEE etc. If you put IEEE, any files that are created here, it will be written overwriting some of these system files. So, that will be detrimental for I mean it will have a corrupting effect on its function. So, make sure that it is in work directory, not in any other directory. And once you had selected this, you can see so many other files. We have already done 2 input AND gate earlier, all those are listed here, whatever is there, including a sequential circuits. And now next step is, let us see, once again we will go into the command summary, and that is what we have here. We had just clicked on library on the bottom left, and next thing you have to do is, the third step is, in model sim prompt, type PWD default library name that you keyed in, say this, this is another directory, in this system it is different. So, what all we want to do is just type PWD as you use Unix command, you can use here, and it is not purely Unix, probably here you can see directory, is it Unix command? So, there might be some difference. So, let us see here. So, in the model sim window here I will just type PWD, let us see what happens. So, what it is reporting is d user rom dvlsi underscore design etc. This is precisely the path we had given earlier at the time of creating the directory, and it is only for if you want to know what is the contents, what files are contained in the directory, just type dir. So, you can see all that. Okay, I can just pull and make it bigger. So, it has listed all the files, including sequential circuits that you have here, test bench and this design, similarly combination circuits all are available in this. So, next is we have seen both here, type directory in the prompt to get a display of all the files in the current directory, and next one is in the main window click on design and then compile. So, what we had to do is, we have already created all the files. I am assuming that you are already familiar with the editor, which I have not shown. I mean, it is deliberate because it is too simple a thing that needing a demonstration of it. So, simplest thing right on Windows can be a notepad, wordpad, which is just child's play. So, you can pick it up if you are not already familiar. And so, here we had to use the editor and create all the source files, test benches and so on, and locate in the same directory that we have already seen. And in main window, next point is click on design and compile. So, having had all the source files, next step is to naturally compile these files. So, that is what is being done here. So, compile HDL source files, menu opens with this condition. So, let us see bloated up, first we will execute that, and this is the command thing, here, and you can either key in here the command, say for example, for compile, if you want, we can say you can type vlog and then file name with a space. Another alternative is just click on the menu here. For example, a design menu is there, and inside that you have a compile here, and just click on that. So, another file opens, we will see a zoomed version of this, what we have here. And now you in this you see all the test benches, including designs, are all listed here. The sequential circuits test benches here, you can click once, then it will appear here, and then say compile. This is one approach. A faster approach is simply double click this, and you do not have to press compile. So, I will double click this here, and before that let us see on the left what happens here on the window. I am double clicking on sequential circuits underscore test. Now, you see it has done the compilation. For example, compiling module sequential circuits, and it has taken the design first, and then it has taken compiling module sequential circuits test bench. So, that always the lower ones are compiled first, and then it moves up to the top, and the top happens to be here the test bench. That is why it has done here. and this module is in work directory. So, you have a top level module name also here, it is not .v or something. So, this is also an important thing that you should take care while loading this design. What you have done so far is only compile the design. Next step is to load the design, and prior to that let us have view the window. So, this was the window here, and all the commands we had keyed in right here, and we used this design, we clicked on this, then clicked on compile here, and you can see that window also here. See, I will zoom this. So, you can see once you click on compile in the design. So, what you have here is compile HDL source files opening out, and remember this was the last directory in which our files are located. So, here you see the listing of all the files here, and what is of interest is the sequential circuits. Unfortunately, this is truncated here, it is actually test sequential circuits underscore test here. This is the design sequential circuits here. Now, we can't move this, that is I also made the mistake, but it drew a line because we are in the paint, right. So, if I draw a line, it will that is it, it is not the real window, the real window is here, right. Here I can move, right. So, what we have done is we have already done the compilation. So, we will dismiss by this window by saying done, right, and we are here, we will come back to this, we will just once again see this. So, we have already seen that we need to just double click this and then press OK, I mean compile, or if you double click it will straight away compile, and which you can see in this main window here, that is what we have seen here, and anything of interest, that is what compile. And once you have done the compilation and there are no errors, and to make it simple for you, I did not inject any errors right now. We will actually cover next we will be covering synthesis tool, and thereafter there also you get involved with compilation, and naturally error will be encountered at that stage as well, not only in this stage of compiling, but also in while loading also you will get some errors, and we have to fix at every stage. Similarly, when everything is satisfactory as far as functionality is concerned, you will move on to the synthesis tool, wherein you do logic optimization as well as map it onto a target device, say a particular FPGA. So, at every step, as I mentioned, you will be encountering plenty of errors to start with as a beginner, and we will have to fix them. So, we will see in after we take up synthesis, we will club both model sim and synthesis together and see and create deliberate errors, so that you can quickly learn and come over overcome that by practice. So, next one is we need to load the design. So, that window is this, and prior to that I will zoom this. Okay, prior to this we will go to the live window, this is the live window. So, once again you click on design and then say load design. After compile there was a load design, a load design window pops up. So, in this if you see you will have that sequential circuits test, there is no .v. So, earlier I pointed out here, it was pointing to the top module as sequential circuits underscore test, that is what is listed here, and mind you it is in work directory. So, this work let us see what happens here. We double click once again here, once again you can make a single click, in which case the same thing will be copied here, and then say add, and this load will light up, and a shortcut is double click here straight away, so that you can dispense with pressing the add here, it appears here. Now, you see work dot sequential circuits underscore test, the top module is sequential circuit test, but you are working in a directory called work, separate directory, and this is mandatory as I mentioned earlier how it is, and it is precisely the same here, that is the library here, out of project and library, this is the sometimes if you click here you may not see this. So, you make sure that is in library. So, now you, next step is to load this. So, in this case press the button load. So, what let us see, here it has successfully loaded. You can just see loading work sequential circuits underscore test, loading work sequential circuits design. It loaded the top one first here and then followed by the design, right. And you can also see here and some of these signals here. So, what top, this is the top module and under that design is there. So, it has loaded here. If it were successful, it will not report any error. If there are some bugs in your code, then it may report error, although it has come through, come clean through compiling, right. Errors can be reported even while loading. And so, before this, let us have a look at the command summary where we are. We have gone several steps ahead. Let us see from this. In main window, click on design compile, that we have already done. Compile HDL source files menu opens. Double click on the decide test bench, say sequential circuits underscore test.v. The test bench and the design will be compiled. Errors, if any, will be reported on the main window. If there are errors, you will have to fix them, and if not, that is what is this otherwise, that means there are no errors, it has successfully compiled. So, what you have to do is just click on done. We have already seen this and we are merely formalizing the reading of this just to make sure that this really serves you straight away. And click on design. This step is what we have already done right now. Click on design, then load design in main menu. Load design menu opens. Double click on the decide test bench, say sequential circuits test followed by load. This is what we have done. The test bench will be loaded into the simulator, right. So far we have done here. So, now next step is we will have to we have loaded the design. First we compiled the design and then now we have loaded the design. Once you load the design, next logical step is to view the waveforms, and in order to view the waveform, there is a menu called view, and you click on that menu and then followed by a sub menu called signals. See, click on main menu view signals, then signal window opens. There is a signal window there that will open, and you can have a look with a zoomed thing here. So, this is the main model sim window, and it has been loaded, that also you can see partially here. And after clicking on view, you have a signals window opened. There is a view, then something sub menu is signals. So, when you click on the signals, this window will open, and in this window you can see so many IOs listed here. It is a very exhaustive list. You can drag this and down, then you can view all this. And it also shows here, right now it is showing a don't care, that is X here, and it means we have not started running the simulator. So, when you run the simulator, you should get the waveforms, right, and because it was not run, we have just loaded the design, and it is showing don't cares here because no valid data is available, and this is nothing other than data at any point of time, wherever the cursor is located on your waveform, and that position whatever is the actual data for a particular signal. For example, if it is D signal, that D signal actual data will be reflected here, and this is the signals window here, and the main window is this. And going back to this view wave signals, you can use this also in order to open the wave first and then go on to select the signals, or you can open this and then you can open in this form also. There are two ways, two approaches, and so are you clear? We can either open the signals window first or wave window first. So, let us see, we have we will see the live window right now. So, what this is view here, and you see here so many listed here: source, structure, variable, signals, and list, process, wave. So, either you can open from wave here or signals. This will be a shortcut. So, I will open signals in the view. So, you have seen precisely the same signals window opening here, and in this you see one view, and that is what we were just reading, view, then wave. Then in this there are three options. One is selected signals, signals in region, in a particular region, and or you can select some of these signals here, or in a particular region you can select those signals. This will not be exhaustive list of the signals, and if you want exhaustive totality of the design reflecting, then you should press signals in design. Let us go for this. Now let us see, we have had another window open here. So now we do not require this signals window any longer, you can just dismiss it off. So if you want, you can just grab here and make it bigger and grab it up, and you see here there is one vertical line here, and you can grab this and then put it anywhere here. Let us say we put it somewhere here, and we grab this line also, put it here, so as to read the signals here listed very clearly. So you can see here, you can this much is not required, because smaller it is better for you. You will have more viewing space here, and you can drag this, and you see here all the sequential circuits underscore test is what is mentioned here. It says D, A, B, C. These are, if you remember, we have handled all these signals earlier. So clock, reset 10, hold, shift, in 1, in 2, trigger, and so on, right? And the order may not really satisfy you, so you can relocate this order, which we will be seeing a little later. And prior to this, let us see where we are in this here. We are in this, in that window, that is in view signals window. In that window, click on view wave signals in design. That is what we have done, and waveform window with the listing of all the signals opens, and this is the waveform window what we have already seen. And in x axis you have nanoseconds marked, right? And next point is, so we have opened the waveform window. Now it is right time for running your simulator. So there is a run all command, and we will first read this and then go on to that. Click on run all menu on the top second row on the right. Click on zoom full menu to view all the waveforms. Other zoom options such as zoom in, zoom out, zoom area, and zoom range may be used to get the decide window. So you can first click on the run all command, and this is the command here. I mean, you can either key in as I mentioned, or it is all menu driven, and you can use run here, and you can also notice some 100 written here. It is called run length, and you can change it if you want. Let us say if I click on top arrow here, it has advanced to 110 nanosecond. This it will be very difficult for you to read, just follow my words, that is enough. If I click on this lower one, it has come back to 100 nanosecond. It can go down, so in how many units it has to go up or down, you can program that also. And here if you see, it says run here, and then it is followed by continue to run, and this one is run all. If you give this run all, then it will start running. You also had a wave file opened already here, and here also you have the very same thing here. For example, if I give this run all here, if I click, it will run, and you can spontaneously you can see the waveforms right on the screen. So I will click on this, let us see what happens. So you see the whole thing become alive with waveforms here, and it also opened your source file, that is the test bench, sequential circuits underscore test. So it is actually entire file is here, and you do not really need, it is a test bench, so which you have already seen. So since you do not need this, we can remove this window. And here what you see here is, we have already spoken about zooming. So these waveforms are so small that you can't see properly here. In fact, you don't see anything on the TV monitor, so here, except for very faint lines, right? And so there is one zoom in here. So let us see, open okay, I will just zoom in. I do not have another window which is zoomed version of this. So, I might have had in another place, I will have to hunt for it. So, before that I will just quickly explain this basic thing. There is one plus zoom in command, there is a lens like thing with a plus mark here, and similarly a minus here. If I click on plus, you see that the waveforms are increasing, right, and it goes every time it zooms by a factor of 2, and similarly you can zoom by a factor of 2 downwards also. So, with a minus thing, and if you click on this one and it says zoom full, and there is one more in between, this is zoom area. You can mark an area and then zoom there. I will just click on the zoom full here, and it has the entire simulation has been condensed into one screen as such. Therefore, you see all crowded signals here. And now let us say we have one more here called zoom area. Let us say we are interested only up to this waveform. So, let us say we zoom from here. Right, only that much portion it has expanded. For example, I can once again put every time you have to press that up to this, that was the last waveform. So, it takes you and fills the entire screen. So, in this fashion you can zoom, and let us go back to the text that we have, and that is what we have done. And there is one zoom area is what we have seen, zoom in, zoom out, and zoom range may be used to get the desired view. So, in zoom let us see the waveform here once again. You have one zoom menu here. In zoom what it says is we have just now seen area marking. There is also the area marking here, zoom area with mouse button 1. So, you can use that. And another thing is range. Suppose you want let us look at this here. So, you see the very same thing, cursor has changed, and I can mark as I had done earlier. So, it has zoomed in the area that you have marked. On the other hand, if you want zoom the entire range, if you click on this one, another window pops up called wave zoom, and a start and end time is marked here. For example, we want, let us say 0 time here, and this is start, I have given 0 nanosecond, and this one I have given say some 26, it does not matter what we have. So, 26 nanoseconds. So, 0 through 26 nanoseconds will have to be shown, and time axis is right here, it is marked in nanosecond. This is 100, 120, 140 and so on. Let us see when we apply, we just press apply, then it you can see here 0 through 26. So, this is 26, that is what we are seeing here, right. And this is pretty difficult to capture all this I have explained, and okay, this is over. So, you can just say OK, and we will just have a look. We have already seen zoom range, and now next thing is let us see how to place different waveforms at desired point. You want to check the functionality for a particular a part of your design. So, what we can do is locate these signals close together and then view this waveform. So, how to do this? So, locate the signal, say reset n and click on it. If you want to locate the signal, click on that signal, it will be highlighted. Click on the highlighted signal, drag up and leave it at the top of all other signals. So, we will just have a look, and I will first read this. Likewise, you can drop all other signals belonging to a function next to the first signal and so on. You can also use cut or copy one or more signals, you can do that, and this is similar to your Windows cut copy operation, and then finally paste all in edit menu and at the desired place. You can also use edit find for locating the desired signal. I mean there are myriads of signals, so you can locate any signal by saying find, and as one example, place reset n clock d q and q underscore n one below another, then highlight all these signals by clicking on first signal followed by shift plus clicking on the last signal. So, you can highlight all this, and the reason for highlighting is we want to change the height. So, we will come back to this, how to change the height, we will come back to this point, and let us go back to the wave. Now, what we have done is we want let us say D is here, this is what we wanted, and reset is here. Suppose you want reset, let us say right on the top. So, what you do is just click on reset and then holding the mouse button drag it right on the top and leave it there. So, the reset n has come over there. This is not the only way, you could have cut here and then pasted here, that is another way, and whatever signals are there right on this page within the vicinity, you can drag like this, and otherwise you may have to use the find, which we will do for the signals not available here. Let us say we want next clock, so we will put it there. Yes.
How do I select a group of signals?
I am coming to that. I have already read that one, I will show that, right. So, next is we have put reset n and clock here, and then what is to be done, what more is there, a D input is already there here. So, what remains to be done is only Q and Q underscore n, and so let us it is not there here. If I am to search here, it keeps on going like this, waveform after waveform, and it may be difficult, although I am able to spot here, right, and with a large design it will be very difficult to spot. So, what we will do is we will straight away use find. So, this is also like if you had used WordPad, you would have precisely used that edit find. So, let us use the same thing. See, let us see here what we want is window opens here, let us key in Q here. Sometimes it does not spot it out, perhaps some bug is there in the software, and sometimes it works. So, you may have to try probably couple of times, I do not know really the reason, and in fact Model Sim has already listed in the help, if you go, lots of bugs reported prior to, and which they have fixed, and obviously some more bugs will be encountered from time to time. It would be good practice for you to report to them, so that they can fix for the future people who use, and we will make one more attempt. If it does not click, we will go on and pick it up from there, right. So, let us say edit find, there is also a search there. So, let us see once again, otherwise we have one more signal called Q underscore n. So, we will hunt for that. So, let us see whether it does. Fortunately it has caught that. So, there seems to be some bug evidently, right. So, now you can dismiss this window. So, we have fortunately Q and Q underscore n located side by side. So, you wanted, your question was how to select more than one signal. It is once again the Windows way. So, just press control and select the other signal for these two. On the other hand, if you want it from here to here, so you click on this and use shift this on the other signal. So, any group we can go, and you can like this, you can keep on going, and hereafter you may have to use control, let us say this, right. All this you can let us say cut and paste elsewhere, and it will be very easy to do that. So, now we will confine our attention to only these two signals, and we will now cut here. In fact, there is a cut available here, scissors here. So, we will paste it here. So, the point is we want it here. So, we will just paste here. What all we have is reset, clock, D, Q and Q underscore n. These are all the signals that we want. Now, let us highlight them, and once you highlight, we wish to increase the spacing between that. Unfortunately, in this software, unlike signal scan or UT of cadence, as I mentioned before, you can't have the height of the waveform manipulated. So, what all you can have is place them apart, more and more apart, right. So, what we do is there is one format here and a height here. So, what you do is, it is the height is in 17 pixels, and we will make it, let us say 50 or 60 or even 90, right. So, and say apply. So, immediately you see the whole thing is changed, right. So, that you can say OK, and then you can view all the waveforms of interest here. See, fortunately all the waveforms that you need are exactly fitting this complete screen. So, analysis you have already learnt. So, I am not going into analysis as such. I just want to show you step by step procedure of invoking different commands. So, going back to this commands, so that is what we have here. Click on format height, wave height window opens, right. Key in 50, we have keyed in 90, followed by apply, OK. All the selected signals are spaced by 50 pixels. Height of the waveforms however remains the same. So, that is what we have already seen. Next is, we want to select the format for each of the numbers. We may have a bus, and it may be grouped as a single signal, or it may be a binary signal. So, you had to select in what format you want it to be displayed, then you use this format. So, I will read this here. Click on format, radix, binary or decimal or hexadecimal or octal as per your requirement, and you can just select from that menu. All selected signals, whatever you have highlighted, those signals only will be set to this, set to the decide numbering system, and then use some arrows are there at the bottom of the waveform. So, you can move them, and there is also a small patch of block here, that also you can drag, or you can click in between the blocks, so as to move all along the time axis, and to move the waveform along the time axis. Unlike the waveforms, this is a timing diagram to check the functionality, which is the real goal as such. And so, we had to this 8 through 11 we had to repeat for all other functional parts of the design. So, this is for one functionality. If you want to test other parts of your design, you repeat from step 8 to this last step here. Step 8 was selecting of the signals that we started with. So, we will resume this, we will have a look at that what we have done here. So, now we want to, let us say this is reset, clock, D, Q, all of them are single bit, right, and you want to you see that on ST, this means some symbolic way of representation. In format we saw on radix, that is what we have seen here, and in this are listed symbolic here, then binary, octal, decimal, then unsigned also. Unsigned is also a decimal number, and you want to get rid of the sign, and okay, I clicked at the wrong point, sorry. That is also a hexadecimal, and if you want ASCII you can have, and default I think is symbolic here. So, let us say here we want all these signals which are already marked to be in binary. So, we just click on binary, radix, format, radix, binary. So, you can see that ST disappeared here in these two cases. Now, suppose I click the cursor here, whatever is the actual state will be indicated here, that is what is here. This is actually 0. So, this Q underscore n is 0, Q is 1 here. So, that is what you see here. At different points it will be different, it has gone 1. So, in this fashion you can click on the cursor at different points and get the actual data displayed here, as I mentioned before. And so, we will see some other signal which is other than say set data we have. Let us see this is also binary. Suppose we want, let us say, counter here, and as I said there is an arrow here. If you move click on this arrow, the waveform can be taken to the right. So, you see 24 nanosecond etc., and if you want move left here, and you can this patch of this block you can move it for much quicker movement. So, you can even press here, it will in between this space, it will take you one screen at a time, similarly here. So, and this counter, let us say it is showing in binary. So, it is showing 4 ones. So, let us set the format for that particular thing signal to, let us say, unsigned. Let us see what happens. So, it was 4 ones. So, it corresponds to 15 in decimal, and if it is in hexadecimal, it is 0f. So, like that you can check at various things. Then if you want decimal number, here it is unsigned. Okay. So, unsigned and decimal, it is not making a difference, elsewhere it will make a difference where signed number is involved, and in this fashion you can go to any waveform and analyze. And going back to this, so what we have here is we have seen up to this. Once you have done formatted all this, if you quit, you have finished the job. And if you quit this software, what will happen, all that you have put, waveforms relocated, all of them will disappear. Next time you enter, again you start from square one. So, you can save that. So, in order to do that, you can use this. To save the waveform format, click on floppy disk symbol or file save format, and in the opened window type sequential circuits .do, then click save, right, and we will see all this. This would complete one session as such, and next time you want to come in, you can start from where you left here. And there are another 3 steps here. I will first show this. So, what we do is we have a screen here. So, you have okay, in the waveform you see a save floppy symbol. If you press this one, it pops out a window here. So, here you have let us say we are doing sequential circuits. So, we can give an apt name here, sequential circuits, let us say, and notice that this is a .do file. So, you click on .do here, this is an important thing. So, you save it as sequential underscore circuits .do. So, you just save here. So, now we can quit this window, you can just remove that window. So, we are here in the command mode now, and now what does it say here? That is what we have seen here in this step. This completes one session. To exit the model sim, we had to quit and then re-enter, right. If you want to, I will just read this. If you want to use model sim again to resume the same project, double click once again, it is same as one there shown earlier, and then click on. Now, this time you have to use a open up project in welcome model sim window, because it is already created, and make sure that the directory is the same as in 3 by clicking on library on the left bottom of the main window and typing pwt to make sure that you are in the correct directory. Otherwise, click file, change directory and select the decide directory. This is like any Windows handling. And final step is load the test bench as shown in 5. That in 5 we have already seen loading of the test bench here. So, you go back to 5 and it is quite simple to follow, and in the prompt field type do sequential circuits.do. So, we have saved it in this fashion. When you in the prompt field you should do this, then only that waveform will be invoked. So, the waveform we saved in 13 will be this. So, the decide waveform with the previously set format is retrieved, that is what. If you do not do this, the previous format is lost. So, you had to make save it and then retrieve it for subsequent analysis. All big designs you can't do complete the entire testing at one go. So, you may have to spread it over many number of days. So, this will tell you how to enter, create a new project as well as to open new projects. For that you need to save this wave file, and that is what we have seen here. Then repeat from 7 to continue with other functional parts testing, which we have already seen. The step 7 is that run, that is a basic thing. So what we will do is we will close this here. 1 minute, I will answer your question, let me complete this. So here what we have done is we have already saved, so we will just quit this model sim and re-enter that. I will show that and then we will see. This time we say open a project. This is already there, the decide project, and then in library we saw work here, and now what we should do is it says do. Before that we have to load the design first. If you do not load the design, you will get error. So first do the loading. So the design is sequential circuits underscore test. So it has successfully loaded. Now you can say do what is the waveform name we have given, sequential circuits, and remember to give that extension do also, then only it can do. Let us see what happens. It says cannot open macro file. So we have to see whether it has been saved in the that particular directory. Test dot do. No, it does not say it. So you can list this directory right here, and you may not find that. So what we will do is we will look at this next time. With this summary of model sim commands are over, and we will have a look in the next class what we have failed to see now, and see what the problem is, and then we will take up a new thing called synthesis, and we are going to have simplify for that. Thank you.